Programmable logic devices allow the control and management of digital systems and have brought greater ease to the management of information in digital form. Among these are some examples such as programmable logic arrays, generic array logic, complex programmable logic device, field programmable gate array. Thanks to this device, we are able to simulate, design, and process the information coming from the actual world to the digital world. All this process is very cheap since no other materials is required to perform the test needed. That is why the technology research areas it is very common to use material description language.
The importance of our description languages is that they offer the possibility for the designer to model the structure and simulate the behavior of an electronic component or circuit before it is built.
This language in combination with programmable device offer advantages such as space reduction, low cost, reduced power consumption. It eliminates the risk of errors when making the physical device. All this allows the development of new technologies and the continuous improvement of the processors we currently use. The challenge consists in integrating the knowledge about counters, state machines, and the domain in general about VHDL to release a VGA driver to display the traditional Pong game on a 640 x 480 pixel 60 Hz monitor. In our case, we choose to use a behavioral design. Our project is divided into three components, which are VGA signal, frequency divider, top layer design. The VGA signal component is responsible for generating the synchronization on the board to display our project on the screen. This is due to two counters that depend on each other and generate signals depending on the resolution required.
Frequency divider has an input signal, which is the clock integrated in the board, that has a frequency of 50 MHz. A process is done to divide its frequency and obtain a clock of 25 MHz, which is the one required to generate the synchronization in our monitor. In our top-level design is where our Pong game is developed. We declare all the components to be used as well as the signals that will be used later. The non-visible edges are taken into account and our game objects are delimited, which are the two paddles and the ball. Each object is assigned a speed of movement and the necessary conditions are created so that it can move according to the two switches on the board.
The challenges that we found when using this new programming scheme was that it was necessary to have knowledge about digital systems to be able to work with a language like VHDL, in addition to the difference that have on traditional programming, because in this case it is necessary to work or consider a new factor that is the time, because it's a fundamental characteristic in real electronic circuits.
Intel, as a training partner, provides us with facilities to develop our projects such as the Intel Light board, with which we use a material description language to implement all our knowledge in 5 weeks and to meet the goal of developing a Pong game.